Okay, I just wanted to do one more example of using the sum formula for tangent, which I've left up on the board here. Just because as we saw in the last example, once you plugged into the formula, there's an awful lot of algebra to do a lot of times to simplify this. And so it is just algebra, but it feels like an awful lot and can be a little bit intimidating. So I wanted to work through one more example together. Okay, so we're going to find tangent of s plus t, and I'm giving you this time tangent of s. But for t, I'm just telling you sine of t is 1/3 and that we're in quadrant 2. Now I said I wanted to work through this together, but I actually want to encourage you to pause the video and try it on your own and then tune back in and we'll work through it together and you can just check your answer. Okay? So go ahead and pause the video. Welcome back. Okay. So I know tangent of s. I'm going to need to know tangent of t. So I'm going to draw myself a picture here. We're told that S is in quadrant 2. Now that's just the simplest way to get into quadrant 2. Here's the reference angle alpha, and there's my triangle. Okay. So I know that sine of the reference angle will just be the absolute value of sine of S, which is just 1/3. Okay. So I can go ahead and label the opposite side 1, the hypotenuse 3, and I need to know what the adjacent side is. So we'll have 1 squared plus a squared equals 3 squared. 1 plus a squared is equal to 9. A squared is equal to 8. A is the square root of 8. And I can see 8 is just 2 times 2 times 2. Pair of 2's on the inside means I can pull one of them out. So a here is going to be 2 root 2. So that means when I go to evaluate tangent of t, it's going to be my two-step process. I'm in quadrant 2, so I know that tangent is negative. And then I just use the reference angle. Opposite over adjacent would be 1 over 2 root 2. And I'm going to want to rationalize that. So we'll get negative root 2 over, now that's 2. These two factors of root 2 give me another 2. So I get 2 times 2, or 4. All right. So now we've got tangent of both of our angles. So we should be able to plug into the formula, and then we'll probably have a bunch of algebra to do to simplify. So first thing I'm going to do is just recopy the formula with s's and t's so that I don't get myself confused having the wrong letters. So it's tangent of the first angle plus tangent of the second angle over 1 minus the product of the two tangents. So now let's just plug in what we've got. Tangent of s we were given is 2/3. Plus tangent of t, we just calculated, is actually negative, so I'm just going to write it as minus root 2 over 4, all over 1 minus 2/3, multiplying by a negative root 2 over 4. I'm just going to bump that negative sign to the front here and make that a positive. Okay. So once again, we do have a complex fraction. I'm going to multiply by 1 in the form of 12/12. 12 is just the product of 3 and 4. It's the smallest number that will cancel both of those denominators. So let's distribute that on top. So I've got 2/3 times 12 over 1 minus root 2 over 4 times 12 over 1. And if I distribute it on bottom, I'm going to get 1 times 12 is 12 plus, let's see, this is 2 root 2 over 12 times a 12 over 1. So now I can cancel. The 3 goes into 12 4 times, so this becomes 2 times 4, which is just 8. 4 goes into 12 3 times, so I'm subtracting 3 copies of root 2. This is just 12, and my 12s cancel, so it's plus 2 root 2. So we've come a long way. We've gotten rid of the complex fraction. I now need to get rid of that root in the denominator, though. So let me clear some space. And we'll be good to go. So what we've got so far is 8 minus 3 root 2 over 12 plus 2 root 2. The way you clear the denominator, or clear the radicals out of the denominator, is to multiply by 1. The trick is when there are two terms, keep the same terms, connect them with the opposite sign. Remember, we call that the conjugate of 12 plus root 2. So it's 12 minus 2 root 2. And if I FOIL out the bottom, that's going to remind me why I wanted to do this. First terms, 12 times 12, give me 144. My outsides and my insides are going to cancel. Don't even need to write them down if I don't want to, but I'm going to just to really emphasize that they do cancel. They're exact opposites of each other, so they go away. And then I've got minus 2 times 2 will give me 4. Root 2 times root 2 will give me 2. So I've got 4 times 2, which is 8. Now I've got to FOIL out the top as well. So first term's 12 times 8. That's going to give me a 96. This is going to give me minus 16 root 2. This is going to give me minus 36 root 2. And then last terms, minus times minus is plus. 3 times 2 is 6. Root 2 times root 2 is 2. So it becomes plus 6 times 2, which would be 12. And if you need to write any of that off to the side, if you need to say, okay, I'm doing negative 3 root 2 times negative 2 root 2. So, okay, the signs are going to become positive. 3 times 2 is 6, times root 2 is 2. That gives me 12. That took me just a few seconds to do. And if that's going to keep me from making a careless mistake, I'm going to do it. Okay. All right, so let's see what we've got. On top, I can combine some like terms. So 96 plus 12 is going to be 108. And these are like terms because they're both root 2's. So I've got negative 16 of them and then another negative 36 of them. So that's negative 52 copies of root 2. And then on bottom we have 144 minus 8, which is going to be 136. We are almost there, but I want my fraction to be in lowest terms. Now I know I can't cancel just that with that or just that with that, but I can see that I could cancel some stuff from each piece. So I can either factor something out from the top and then cancel, or I can distribute the division and then cancel two fractions. I'm going to do it both ways just because people may vary on what they prefer. Looks to me like 4 is the biggest thing I'm going to be able to pull out. So I'm going to try factoring out a 4 on top, and that's going to go in, that's 27 minus 13 root 2 all over 136, and 4 goes into 136. I know that. The trick is if it goes into the last 2 digits, 4 goes into 36, so it goes into 136. Okay. So let's see, how many times does it go in? 34 times. Yes? 4, yes. Okay. So this becomes 27 minus 13 root 2 all over 34. That's a perfectly acceptable version of the answer. If you prefer to distribute the division, you could come from here to 108 over 136 minus 52 root 2 over 136. Okay. And so now 4 goes into both the top and the bottom. So 4 goes into 108 27 times and into 136 34 times. So this becomes 27 34ths minus 4 goes in here 13 times and here 34 times. So minus 13 root 2 over 34. Okay. Those are equivalent answers. If I combined these with a common denominator, I'd get this, or if I distributed the division, I'd get this. So whichever way you're more comfortable with is totally fine. But I want to make sure that I've got fractions and they're not complex fractions, so just a simple fraction. When I've got roots, I want all the roots simplified, so I pull out as much as I can. No roots in the denominator. And anytime I've got fractions, I want to make sure they're in lowest term.